Sum primes, we have so much faith in RSA, we give you not just the product of the primes, but their sum as well. And I love squares. Okay, that's their hint. So I've got some Python here that's going to solve this. We know they gave us the product of the primes, that's n. They gave us this other thing called x, which is the sum of the primes. So if we do a little math, n is p times x minus p, right, because q is x minus p. So therefore, n is equal to p times x minus p squared, which means p squared minus px plus n equals 0. That's a quadratic formula. We can solve a quadratic formula for p with a is 1, b is negative x, and c is n. So what we get here is a quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So I've got, because those are going to be really big numbers, I found a integer square root algorithm on the internet. So that's going to compute the square root for us. I took these numbers out of the file they gave me. So p is b plus the square root of b squared minus 4ac all over 2a. Q is the minus there. I print them out. I make sure they equal n. E is 65,537. They gave us that in the Python file. I compute d just the way they did. The plain text is then the ciphertext raised to the d power, mod n, and I print it out. So Python 3. And then I can take this here. We'll go for some hex to ASCII. And there is my flag.